Megan, or there we go.
This meeting is being recorded.
Wow, that was loud. All right, thank you for coming along, everybody. Welcome to the ESIP Information Technology and Interoperability seminar series. This year we are calling it the IT&I Rants and Raves, where we're hearing from people from all over the community, talking about the things that they can't believe we're still doing, or things they want everybody to know about so they can do it more. This month we have Kyle Onda, who is the executive director now, right? Of
it's just director.
The director of the Internet of Water initiative at the Lincoln Institute of Land Policy's Center for Geospatial Solutions. Kyle and I work very closely together, and he's done some really cool work in the water data interoperability and kind of community data space. And he has a rant and rave for us about standardization in the water information ecosystem. So I won't go any further than that. Thank you so much for coming along, Kyle. I'll let you further introduce yourself and take it from there. So thanks a lot.
Thanks, Dave. Let me get my slideshow going. Okay. People are seeing an actual. Okay. People seeing slides now?
Not yet. There we go.
Okay, great. Let's move that out of here. Okay, cool. So I've titled this thing my rant and rave, navigating the AntiCommons, which I'll get into. I come from a social science background, so that was fun to apply this idea. And I'm talking about kind of open data and API standards in practice. And that's just coming from my experience with this Internet of Water project, which is trying to get folks in the water information space to use open data and data exchange and API standards. And I'll get into that in a bit. But this is really informed by on-the-ground experience, trying to get folks in really state and local agencies to do this stuff. So I'm going to start out with just the parable of the tragedy of the commons. Most of y'all probably know this, but it's this idea when you have a non-excludable or common good, like grazing lands or a groundwater aquifer, which is rivalrous or scarce, meaning that every bit you take is a bit that I can't take of it, right? It's a depletable resource. That everyone left to their own devices will use it, and then it will be all used up, and there's the tragedy. And classically, right, the two ways around this are to enclose it, to privatize it, to divvy it up to people who then use it sustainably because they have a private incentive to do so, or you come together as some sort of community and cooperate and create a regulatory framework where you monitor everyone's use and provide incentives to use the resource responsibly. This is well known. There's a lesser known kind of tragedy called the AntiCommons, which is the mirror image. And so this is for when you have a resource that's technically easy to exclude people from, right? Meaning you can put a fence around it and keep people out, no problem, in a sort of technical sense. But it's non-rivalrous, meaning that if one person uses it, that doesn't mean another person can't use it. It's not like consumed. So a classic example of that is open data, where scientists have put a lot of effort into making data, and they don't necessarily want to share it because even though that would be very useful to everyone, for everyone to have access to everyone's data all the time. And this problem which is born from an excludable and non-rivalrous resource which has split ownership rather than being held in common, leads to inefficiency and underutilization of the resource. And classically, the two ways around this are, one way is to expropriate, or steal it from the property owners. So in land management, this would be something like eminent domain. In science, this could be public data archiving requirements. If you receive this funding, you have to put it out in public. I put the EU knocking down Apple for Lightning too. You can just impose a standard through some coercive means. When we're talking about interoperability, or you can do it by deal, right? You can bundle the costs of contributing to the commons with benefits. And so the clearest sort of example of this is land readjustment. So on the left, we have kind of a disorganized urban environment where lots of people built houses willy-nilly, and so they own the property all over the place, and it's kind of inefficiently laid out. And so in these projects, which are common in sort of, or which were common in kind of developing country informal settlement areas, is you can regularize it. You can get people to accept the deal where they move to a smaller, more compact piece of property that's laid out in a more regular way. And then there's more land to be used for better purposes. There could be open space, it could be commercial space, and then the incentive to get people to do that is, they get better access to open space, and maybe they get tax revenues and better infrastructure associated with the commercial property. Okay, so, but the theme here, which I hope is linking back to data interoperability, right, is point is there's fragmentation, and we want individual data owners to standardize their data, but that has a cost to it. If everyone did it, there'd be benefits to everyone, but in the meantime, it's costly to standardize your data from whatever native format you're using for your own primary use case. All right, so coming to the Internet of Water. So the Internet of Water started as this Aspen Institute dialogue series. I came out with this report, and this was sort of the headline finding, right? So there are key questions about water that very hard to answer, like how much there is and what quality it has and how's it being used. And the issue is that the data relevant to these questions is being collected by all kinds of different actors for all kinds of different primary use cases. And it's super hard to assemble them to answer questions faced by the larger community. So as an example, right, I put in a link to a stream gauge cataloging work that Kendra Kaiser at Boise State University did. Right, so if we look at Oregon, Washington, and Idaho, if we're just looking at stream gauging, surface water quantity data, there's 853 active real-time USGS sites in those 3 states. And that data is pretty nice and accessible and standardized. And meanwhile, 16 other organizations, each with unique data systems with varying degrees of interoperability, have another 461 stream gauges. The extent to which this is used actually is kind of unknown. I suspect for many use cases, people just go to the USGS for a combination of trust and because it's the only source of stream gauge data that they might bother to know about. And this just seems like an underutilization of the great resources and great information that might be carried by these 461 other gauges. So the report came out with a series of principles which have been revised over time. And the key ones are, oh wow, I was a slide behind, I'm sorry. It's okay. we'll just keep going. The two key principles or two of these principles, I won't go through all of them, were all water data produced for the public good should by default be findable, accessible, interoperable, and reusable, either for public use or for authorized users. And then number 6, commonly accepted data, metadata, and exchange standards should be adopted by water data producers. All right, so we're asking people to please standardize their data so it's more usable for everybody. Good enough. This crowd should be familiar enough with that sentiment. All right, so, you know, here we are 6 years out or so from when that report was made. And now there's this thing called the Internet of Water Coalition, which is this kind of loose confederation of water relevant organizations, including my shop at the Center for Geospatial Solutions, Duke University, which originally convened the Aspen Dialogue Series, people like Kuwazi and the Water Data Collaborative, and then government and quasi-governmental organizations like federal agencies, state agencies, intergovernmental groups like the Western States Water Council. And they're all involved to varying degrees in activities to try and get each other and others to come aboard with water data standards. All right. So open data, right? This is a different problem than the cartoon I showed first. Of the person who doesn't want to put their data in an open data repository. Because usually public agencies often nominally make their environmental data publicly available as part of their mission or government policy. There are some cases where they're disallowed from doing so for data security reasons, but by and large, environmental agencies make their environmental data nominally publicly available. But usually only in a format which it was produced for its original use case, or in access modes made available by big open data or water data kind of management software vendors. And I won't call them standards, but the modes of access that they have made available. And not necessarily in mind to be totally interoperable to allow for a broad cross-section of secondary uses. So, you know, going back to the metaphor, what's actually the role of these common community data and API standards? Why would organizations adopt them if it costs them to do so? And presumably they're already using the data that they do have operationally for their own purposes. So why would they adopt another data standard on top? Or what could be in it for them? So nominally, they're supposed to facilitate data exchange and use in data pipelines and user interfaces. So many of you might be aware of things like Water ML2 and the OGC APIs like Sensor Things API and the OGC API in quotes family. They're designed to do this. And there's some degree of use, you know, of all of these things, but I wouldn't call them particularly widespread, particularly below either the federal level or outside academia. There's a lot of text here, but don't worry, I'm going to walk through it. So in my 4.5 years or so working on the Internet of Water with a variety of state agencies, I've seen a lot of different ways that people make data available for secondary use and for bulk data access. And at the top, it goes from bottom to top, less to more common. So starting with the most common, right? We see a lot of bespoke file formats, native vocabularies available sort of on websites, or sometimes you still have to email people for them. And progress made. Sometimes those files are available via generic open data catalogs in things like CCAN or Socrata. And so data is being made available, but it's not particularly interoperable with anything else. But it's out there and reasonably discoverable if you know where those websites are to begin with. The next category are kind of exports from either commercial off-the-shelf software or exports from purpose-built graphical user interfaces that were designed with sort of a general public use case or a very targeted audience. Right, a dashboard built for the agency's primary users. This often means that they're not optimized to be interoperable with anything else in particular. And for common scientific or private sector kind of real-time monitoring use cases, they're essentially being asked to be scraped. I think the Safe Drinking Water Information System is a good example of this. I'll show another visual in a bit. But these are kind of the most common things I see after just posting native format files on the web. Also see a lot of bespoke exports and custom APIs being built. These are pretty good, allow people a good deal of access, but again, there's no necessarily use of standards other than high-level meta standards, like using an open API spec or something like that, or following RESTful principles. Again, and then finally, the least common is I see application of community standards for various reasons. And these rarely are underpinning an actual user-facing tool. So these tend to be useful for programmers and analysts who can write code and who develop data pipelines and software. And so in my mind, the relative rarity of the implementation of these, within state and local agencies undercuts a lot of the purported benefits of the standards relative to someone just doing the custom API. So just for kind of an illustration, we'll look at stream gauging in Nebraska now. So USGS has 142 real-time sites here. And if you're familiar with NWIS, right, you'll be familiar with the legacy web services, and you can get that in their RDB format or WaterML2. Very nice, very good. And USGS is also experimenting with some of the OGC standards. So there's an OGC API features kind of spec that outputs the data in kind of a custom GeoJSON format. And more recently, they put up Sensor Things API, which has its own various JSON and GeoJSON and CSV output formats. And of course, they have a nice GUI with the water data dashboard, as well as the traditional Streamflow maps, where you can get a quick peek at the data and charts visually. Okay, so what's going on with the state agency? The Nebraska Department of Natural Resources has 248 real-time sites. And they have 3 ways to access that data. One is you can email them for it. Another way is they have a software vendor that manages the actual data, and that vendor has a user-facing portal that you can go to and kind of point and click around and select the gauges you want data from and export it in a CSV format that's native to that vendor. And then they've implemented, that vendor doesn't have kind of a user-facing API. So they've implemented their own custom API, which is pretty easy to use, and custom JSON format. Again, so good data coming out, but still kind of fragmented if I wanted to integrate the USGS and Nebraska gauges. There's still basically ETLing that has to go on. And so what's going on, right? I think USGS, relatively well-resourced agency with a strong public access kind of data mission, sees open standards as part of its mission, and so has made those kinds of investments. And it's my understanding that behind the scenes, right, they have their data management vendor too. And so USGS itself is making the investment to essentially ETL data from that system to different databases that they can layer OGC standard interfaces on top of, and standard output, standard data exchange format outputs on top of. Okay, so the Nebraska agency also prioritizes public access to its data, but it's less well resourced, and it's not as efficient to use a graphical user interface that's furnished from its data management vendor. And that data management vendor doesn't implement a suitable public-facing API at all. So they built their own directly on top of the data system from their vendor. So they've either been unaware of community standards, or it's both. They've chosen to allocate their resources to connecting to the data management vendor backend as easily as possible, rather than furnishing community standards, which are maybe more complex to implement. So what I see going on, and that's just one example, but what I see going on a lot is organizations have limited resources. And the more limited the resources, the more organizations are going to prioritize meeting the needs of their historical and active user base rather than potential future users or secondary users. So therefore, in the absence of something like an open data standards mandate, which has happened in a couple of places, but absent that, they're going to focus procurement on tools that provide off-the-shelf internal and external tools for their existing user base, are easy to administrate, and have clear support, have clear sort of support networks or vendors. These tools tend not to implement community standards, and certainly not the newest ones, for reasons that make sense. And so secondary data users thus face this sort of at least weak form of the AntiCommons, where they can find the data, but it's fragmented and kind of difficult to integrate, and therefore it's underutilized. So maybe this isn't earth-shattering to anyone, but I'm finding standards are not enough to break the AntiCommons, standards are giving in terms of public agencies, right? Standards are giving them blueprints when they need houses. They need tools that meet use cases. The standards are sort of secondary. So I've been pondering the idea that maybe data exchange and API standard setting activities at bodies like the OGC or OSGO should actively support the development of not only reference analysis software, reference data management software, or reference API implementations and servers, but also clients. And similarly, API standard setting bodies might want to prioritize community standard output formats, right? Linking the data standards with the API standards in their specs. But moving to like the Rave part, I think we are moving in that direction. I think some of the newer community standards, the OGC API standards, are very friendly for client developers. The APIs themselves are beginning to have very solid open source reference implementations that are pretty easy to at least get public agencies to experiment with deploying in the Docker era. And finally, there was another presentation in this series earlier about agile procurement, and these frameworks are at least giving public agencies sort of the framework to develop in this way, to think about to think about use cases perhaps a little more flexibly, to integrate data standards into their procurement processes as goals and build flexibly off of them. So here's an example from New Mexico, from the New Mexico Water Data Initiative. So where they've been able to, over a few years, get five and counting separate agencies to implement the Sensor Things API, all using the Frost server, which is a nice reference implementation. And so they got 5 separate agencies putting out data in this format. They can also pull in the USGS data, and they can get software developers to pump out user interfaces for a variety of use cases pretty quickly that uses all this data in a federated way. And that's been great to see. I think, right, in the OGC API family, we have these nice reference implementations that are open source, like GeoServer and Paiju API. And I'm more experienced with the Paiju API side, but that setup is super plugin friendly. I think Tom Kralidis, the lead on that, had another presentation earlier in this series. But in our experience, junior developers can easily write plugins that essentially proxy backend data sources to OGC API family outputs, and then focus UI development based on the OGC API family. So we have an example here that was done by a fairly junior software developer in not a very long time that can effectively proxy the US Bureau of Reclamation API. There's actually a chain of API going on here. So it's converting it to Sensor Things API and then OGC API features. This might take a while to render, but the point is we can start to get pretty nice user interfaces from existing non-standard APIs via proxying to standard APIs from multiple sources. So that's been great to see. And then another one that we're starting to toy with more on the metadata level, but some people's metadata is other people's data, is using JSON LD, JSON for linked data, as a data exchange method. For those who don't know, basically it's a way to slap on a context. So I have a JSON document here, and we have this context sort of block, which can essentially map the other elements in the JSON document to an unambiguous vocabulary. So this can be parsed by a JSON LD parser, something like this, to a series of statements that use unambiguous identifiers for the things we care about and their attributes. So as an example, right, you could imagine USGS monitoring location pages could actually structure the data using JSON LD this way eventually, where you don't necessarily even need a standard output format. As long as you are outputting data that's mapped to unambiguous vocabularies, they become easy to parse, as long as people are referencing the same vocabularies. And so you can imagine different organizations have very different data structures, but by using contexts, they're telling the world, hey, my data means this in a standard vocabulary. And we've done that with Paiju API. We've made contributions to an open source project to allow people to implement JSON LD templates into the HTML output of feature level of individual features in the OGC API features context, which makes it pretty easy for data providers to translate their data to domain models and standards on the fly. And then clients can work up with the JSON LD to kind of integrate data from multiple sources that are using this. And we're piloting that to good effect, and we'll see where that goes, but I think it's promising. So my overall conclusion is, for all but the most well-resourced agencies, it needs to be super duper easy to implement data standards to get wide adoption, to really realize the benefits of all of this data that's out there, that's being collected by fragmented agencies. And it's been hard going in the water data community, but it's getting easier. It's getting easier. So thanks. I'll just put in a plug for my shop, which is the Center for Geospatial Solutions, which does all kinds of things with geospatial data, not just with water data. And I'll open it up for Q&A, I suppose.
Awesome. Thank you, Kyle. I have a few things, but I'll open the floor to anybody who wants to come off mute and ask questions or drop in the chat. So go ahead. If I didn't know better, I'd think you were drinking hydrogen peroxide.
It's a big
bottle.
bottle. Yeah.
Oh, it's kombucha. Nice. So, your bottle was fuzzed by your backup filter. Couldn't tell. Well, if nobody wants to jump in right away, this morning I saw a post on Mastodon pointing out the number of file formats that GDAL supports versus, say, Evan Rualt, he was commenting on how GDAL supports about 250 file formats. And in the neuroimaging world, there's only like 10. And I was thinking about that in the context of, just while you were talking, I was like, oh my goodness, you know, in water data, intersect geospatial with sensors and various other domains. And here we are with potentially, you know, 300, 400, 500 formats ostensibly that we actually have to work with. I don't know, it's more maybe a comment as much as anything, but I guess what's your take there? Like, why do we have such diversity? Is there a reason for it? Like, what's the source, and is there a way that we could address the source of the issue more directly?
Yeah, I don't know. Like, water data is interesting. I think the most cynical part of me just thinks that there isn't a market for water data in the same way that there is a market for, say, financial data or medical records data, because water isn't, and for good reason, water isn't a market resource in the same way. So therefore, data about it isn't sort of on the market in the same way either, which doesn't drive. So there hasn't been a big drive to actually consolidate everything. Also, water is just it's a big field. Like MRI imaging, there's only so many kind of areas of substance matter expertise that there are going to be. So I think that's the big macro reason. Yeah, because a lot of it's not like with MRIs where, yeah, there's a lot of custom research that goes on, but ultimately, you know, Medicare is paying for like a lot of it. There isn't like a single buyer that's driving standardization in any way in water data.
Yeah, I think the diversity, my take on that is the diversity of use cases is just so broad that inevitably we end up with lots of different takes on the way things should be done. yeah, there's no one driving focus. So
Yeah, I think.
uh-oh.
I was thinking
Let's
about putting XKCD 927 in there.
That Nels beat you to it. And you know the number. I love it.
Yeah, that's definitely part of it, and part of why I think the way forward is more thinking about ways to flexibly translate things on the fly if need be, and that way people can sort of build whatever interface they need to without necessarily having to ETL everything into a standard database over and over again.
This conversation reminds me of a few that I've had here lately about data in general, proliferation of data across different platforms, different vendors, and especially into the sort of cloud computing era that we're working toward pretty heavily. But we are reinventing the file system, the concept of block storage and a file system that is what got us to this place in the beginning, right? You know, how do we index things? How do we efficiently find a piece of information given some location, some offset, whatever that might be, and the amount of sort of virtual file systems that we built on top of that over the last 20, 30 years. I mean, VRTs are a great example of a virtual file system built on top of block storage. At some point, I think it's worth as a community to try to expand out from, you know, the data science perspective back to the hardware perspective and say, okay, are we not learning from what you guys have done for a long time on how to make this better?
Yeah, I think that's an interesting perspective. I think it is a good. I myself have evolved where, like, when I first took this job, I was like, yeah, we just pick some standards and hope, and go with those. But yeah, I think Dave's right. The diversity of use cases is too great, and so instead thinking about, it's really about providing efficient access and easily parsable, make it easy to understand the data structure, even though the data structure itself might be different. But making that documentation of the data structure very, very simple, and very easy parsable. And that's where a lot of that's where the JSON LD comes from, right? That's the schema.org. There's all this information on the internet. Can we give people tools to describe it in a standard way, but a flexible way? I'm thinking that's, anyway.
Yeah. Yeah, the analogy, Nels, the analogy you're drawing there is like the one I've used, either standardized ingredients in recipes, or standard mixers to make mixed drinks. It would seem absurd to invent new ingredients and start replacing them in recipes, but that's what we do in IT all the time. And as these systems mature and as our IT approach matures, we'll see broader adoption of standard components, basically, for these what are now in some ways common use cases. But it's still early in a lot of ways in these interoperability arrangements that we're working with.
Yeah, I see Emilio. Yeah, standards being a moving target is a huge one, and that's part of my point. I'm like, standards are still good to implement if you can, But if standards are going to be changing all the time, I think we need to be giving people reference implementations that can be tied closely to use cases to get people to get large number of factors to use them at all. Because otherwise, yeah, what's the return on investment on investing in a standard that we also have to build a custom client for, and that also might not be the latest and greatest standard in 5 years.
All right. Well, anything else? I see a few other things in the chat here. Pretty much in line with what we've been talking about. If there's no other discussion, we can call it. This is a good set of things to be thinking about. And certainly, I think the intersection of what you were talking about and federal IT contracting is what I'm thinking about personally, but that's because that's where I sit. I think there's a lot of things we can and should be doing to push from the public sector on getting to a place where the systems that people are buying just work together and not end up in this place where vendors are all, well-intentioned but ending up developing and delivering things that don't meet the needs of a broader integration. And yeah, I very much look forward to seeing how the situation unfolds. So, unless there's anything else, go ahead, Nelson.
I just want to add some context. I dropped a link in the chat that's not really relevant from a technology perspective, but from a philosophy perspective, I think in data and standards, but it's one of my favorite sort of adaptive change philosophies in software is the live ahead concept. But in order to do that, and as standards evolve and as we learn and as we grow in how we serve this data, how we organize it, how we represent it, how we translate it, whatever it might be, having a standard is great. We know it has to change, but providing that upgrade path, providing the tools and utilities that can come out and say, here's a new standard, here's the latest and greatest way to do it, and here's everything you need to move from the old to the new one quickly, efficiently, without a lot of work, without having to completely retool everything you're doing. We have to be able to provide as much of that automated support as we can.
Yeah. All right, very good. We'll get a few notes and recording up and share it out to the community. I have a few ideas for who to have on next month. But if anybody has any topics that they would like to hear about, please reach out, let me know, and I can do a little work to find somebody for next month. But I don't have anybody specific lined up just yet. And unless there's any final words, I would thank everybody for coming along. Thank you so much, Kyle, for the insightful talk, and call it a day. Give everybody a few minutes.
Thanks all.
Cool. Thanks a lot. Take care.